Welcome. Today we're diving into the fascinating world of time series predictions. Time series data is everywhere, from stock prices to weather patterns and even your daily step count. Understanding how to analyze and forecast these data points can unlock powerful insights for businesses, researchers, and everyday decision makers. In this video, we'll explore what time series data is, why it matters, and how predictions can help us anticipate future events. Let's start by defining time series and setting the stage for our journey into forecasting. Time series data consists of observations collected over time, usually at regular intervals. Think of daily temperature readings, monthly sales figures, or hourly website visits. Each data point is timestamped, allowing us to track changes and patterns over time. This structure is what makes time series unique compared to other types of data. By analyzing these sequences, we can uncover trends, seasonal effects, and even random fluctuation. Understanding the basics of time series is the first step toward making accurate predictions. Predicting time series data is crucial for planning and decision making. Businesses use forecasts to manage inventory, schedule staff, and set budgets. Meteorologists predict whether to inform the public and prepare for emergencies. Even individuals rely on predictions like planning travel based on weather forecasts. Accurate time series predictions can help avoid costly mistakes and seize opportunity. By understanding the importance of forecasting, we can appreciate the value it brings to various fields. Time series data is made up of several components: trend, seasonality, and noise. The trend shows the long-term movement, like a steady rise in sales. Seasonality captures regular patterns, such as increased ice cream sales in summer. Noise refers to random, unpredictable variations. By breaking down these components, analysts can better understand the data and build more accurate prediction models. Let's look at each component in detail and see how they influence forecasting. Trend analysis helps us identify the overall direction in time series data. For example, a company's sales might steadily increase over years, indicating growth. By isolating the trend, we can make long-term forecasts and strategic decisions. Analysts use techniques like moving averages and regression to spot trends. Understanding trends is essential for predicting future values and planning ahead. Let's explore how trend analysis works and why it's a key part of time series forecasting. Seasonality refers to repeating patterns in time series data. For instance, retail sales often spike during holidays and electricity usage rises in winter. Recognizing these cycles allows us to make more accurate predictions. Analysts use techniques like decomposition to separate seasonality from other components. By understanding seasonal effects, businesses can prepare for busy periods and optimize resources. Let's see how seasonality impacts forecasting and why it's important to account for these patterns. Noise represents unpredictable fluctuations in time series data. These random variations can make forecasting challenging. While noise can't be predicted, analysts try to minimize its impact by smoothing the data and focusing on underlying patterns. Understanding noise is crucial for building robust prediction models. By separating noise from meaningful signals, we can improve forecast accuracy and make better decisions. Let's discuss how to handle noise in time series analysis. Visualizing time series data is a powerful way to spot trends, seasonality, and anomalies. Charts and graphs make it easier to interpret complex data and communicate findings. Tools like line charts, scatter plots, and heat maps are commonly used. Effective visualization helps analysts and stakeholders understand the story behind the numbers. Let's explore some popular visualization techniques and see how they enhance time series analysis. Preparing time series data is a critical step before making predictions. This involves cleaning the data, handling missing values, and transforming variables. Proper preparation ensures that models are built on reliable information. Analysts often use techniques like interpolation and normalization to improve data quality. By investing time in preparation, we set the foundation for accurate and meaningful forecasts. Let's discuss best practices for preparing time series data. Stationarity is a key concept in time series analysis. A stationary series has constant mean and variance over time, making it easier to model and predict. Many forecasting methods require stationary data, so analysts often transform series using techniques like differencing. By ensuring stationarity, we improve the reliability of our predictions. Let's explore what stationarity means and how to achieve it in practice. Autocorrelation measures how current values in a time series relate to past values. High autocorrelation means past data strongly influences future points. Analysts use autocorrelation plots to detect patterns and select appropriate models. Understanding autocorrelation helps us capture dependencies and improve prediction accuracy. Let's see how autocorrelation works and why it's important for time series forecasting. There are many methods for forecasting time series data, each with its strengths and weaknesses. Common approaches include moving averages, exponential smoothing, and ARIMA models. Choosing the right method depends on the data's characteristics and the prediction goals. By understanding the options, analysts can select the best tool for the task. Let's review popular forecasting methods and see how they're used in practice. Moving average technique smooths out short-term fluctuations and highlights longer-term trends. By averaging data points over a window, analysts can reduce noise and focus on meaningful patterns. This method is simple yet effective for many forecasting tasks. Let's see how moving averages work and why they're a popular choice for time series predictions. Exponential smoothing assigns more weight to recent observations, making it responsive to changes. This technique is useful for forecasting series with trends or seasonality. Analysts can adjust the smoothing parameter to control sensitivity. Exponential smoothing is widely used in business and economics for its flexibility and accuracy. Let's explore how this method works and its advantages in time series prediction. RIMA stands for Autoregressive Integrated Moving Average. It's a powerful model for forecasting time series data, especially when the series is stationary. ARIMA combines autoregression, differencing, and moving averages to capture complex patterns. Analysts use ARIMA to make short-term and long-term predictions. Understanding ARIMA's components is key to building effective models. Let's break down how ARIMA works and why it's a cornerstone of time series forecasting. Evaluating prediction models is essential for ensuring accuracy. Analysts use metrics like mean absolute error, MAE, and root mean squared error, RMSE, to measure performance. Comparing models helps select the best approach for the data. Continuous evaluation and improvement lead to more reliable forecasts. Let's discuss how to assess time series models and interpret evaluation metrics. Outliers are unusual data points that can distort predictions. Identifying and managing outliers is important for building robust models. Analysts use visualization and statistical tests to detect outliers. Depending on the situation, outliers may be removed or adjusted. Proper handling ensures that forecasts reflect true patterns and aren't skewed by anomalies. Let's see how to deal with outliers in time series data. Beyond basic models, advanced techniques like machine learning and neural networks are revolutionizing time series predictions. These methods can capture complex patterns and handle large datasets. Analysts use algorithms like LSTM and Prophet for sophisticated forecasting tasks. By leveraging advanced tools, we can achieve higher accuracy and tackle challenging prediction problems. Let's explore how advanced techniques are shaping the future of time series forecasting. Time series predictions are used in many fields, from finance and healthcare to transportation and retail. Banks forecast stock prices, hospitals predict patient admissions, and logistics companies optimize delivery routes. Accurate forecasting improves efficiency, reduces costs, and enhances decision-making. By understanding real-world applications, we see the impact of time series predictions on society. Let's look at some examples of how forecasting is used every day. Predicting time series data comes with challenges, such as missing values, changing patterns, and external influences. Analysts must adapt models to handle these issues and maintain accuracy. Continuous learning and model updates are essential for reliable forecasts. By understanding challenges, we can develop strategies to overcome them and improve predictions. Let's discuss common obstacles and how to address them in time series forecasting. Cover the essentials of time series predictions, from understanding data components to exploring forecasting methods and applications. As technology advances, new tools and techniques are emerging, making predictions more accurate and accessible. Whether you're a business leader, researcher, or curious learner, mastering time series forecasting can open doors to better decisions and new opportunities. Thank you for joining this journey. Stay tuned for more insights into the world of data and prediction.